Internally, Story got funding to develop a workbench, a development environment for building out a scan and plan application. The goal of the project is to, without writing any code, can we create a tool where you can bring in CAD, create your environment, configure all the motion planning, and be able to do planning and execution from within the development environment. So I'm going to go into more details on the different components of that. So we can move to the next slide. Before I get started, just the team members, the main contributors at this point is Jeremy Zoss, Michael Ripperger, David Merge, Josh Langsfeld, and Benjamin Young. He was an intern this summer, supported this effort. We're about halfway through the effort, so I think we wrap up in December. Next slide. Okay, to kind of give an overview, so we're in the phase 1 of this effort. So we wanted to create about 5 different editors. So there's the environment editor. So that'll allow you to import, export URDFs, create URDFs from scratch. It also provides tools around creating convex holes, convex decomposition, and configuring properties that you typically would in the URDF. The next one is kinematics editor. So this is assigning different types of kinematics, inverse kinematics, things like that. The next 3 are specific to Tesseract. And those will be generating your, customizing your planning pipeline. Like you want to do individual rasters, or do you want to do a global plan first? You'll be able to do more of a model-based approach to configuring your own pipeline. And then the planning editor does defines the costs and constraints and things like that for the different planners. And then the command language editor allows you to write like a teach-pendant program. So you'll be able to write out a program and run it through your planning pipeline and be able to visualize this within this workbench. And then we plan to do a first deployment later this year. Next slide. Okay, so we did a study of looking at different platforms to build this off of. We looked at Ignition, FreeCAD, there's like Open Cascade and things like this. So we went through and looked at all those different ones, and we ended up settling on FreeCAD, which is an open source parasolid modeling software, very similar to like SolidWorks. And we plan to implement these different workbenches within this framework. So the nice thing about it, it is free and open sourced. So it allows us to incorporate these different tools into it without having to purchase a license. So the main thing is that we get a lot of things for free, right? We get all the CAD and Parasolid tools for free, the visualization, the tree and property editing. So it brought a lot to the table compared to some of the other platforms we were looking at. So it allowed us to get things up to speed fast. Next slide. All right, so we started on 2 workbenches that we've been working on over the past month. The first one is the environment editor. So as previously mentioned, it allows you to create a URDF from scratch. We'll show a video of doing that. Import an existing URDF, and also import multiple ones, right? You're able to bring in different URDFs and it kind of just inserts it into the tree. Create convex holes, convex decomposition, and then the nice thing about building it into FreeCAD and using it, you get access to all their saving functionality, right? So you'd be able to save this, reopen it, and back to the same state. So this is an example one, and we will show a video coming up on 2 different approaches of building one from scratch and next. So you can see here, he's got a link selected, and it's very similar properties that you would see in the URDF, right? The joint axis, the min, max, type, and things like this. You can also drag and drop, reconfigure things within this, and the visualization opens up or updates. Next slide. So it's just an example of showing the convex hull type of visualization. So you can bring in your CAD model with a click of a button, it creates a convex hull and you can visualize it for creating collision geometries. Next slide. Another common thing that we do is you may not want to do just a convex hull, the whole thing. You may want to break it up into multiple convex hulls. So we've integrated, I think 1, maybe 2 algorithms right now for decomposing the detailed mesh into multiple convex hulls. And that's kind of what you see here versus the previous slide for collision geometry. Next slide. So this is a video. So this is of importing an existing URDF, and it's kind of just showing you changing different properties of a joint. Just showing an example of doing that. And you can visualize turn off the collision visualization and the collision. All right, the next one will actually show building URDF. So you got the picture on the right, which is the industrial robot, and he's just going to demonstrate adding a link, importing the STL, converting it to convex hull for collision geometry. And it's just showing this. This is playing at about 10x speed, I believe, is what it is.
That's any good robot video, right?
Yeah. Is it still playing or did it stop? I think it stopped playing.
Yeah, I think that's the end.
Okay. Yeah, so it just show an example of pulling in existing geometry and building out the URDF. So the next piece of this is to work on the exporting. That is the one piece that we're currently in the works of getting to take this now that you've built it and exporting it out to be able to use within a ROS system. Next slide. So that's the URDF that we just talked about, building that, creating your environment. The next workbench that Ben Young worked on was implementing the command language that allows you to build out a program very similar to what you would do on a teach pendant, right? You have a series of waypoints, you can add those different waypoints. Eventually you'll be able to import those, set up your manipulator info and define plan instructions, weight instructions, set tool, set analog, things like that. And the goal is that you will then be able to send this to the motion planning framework and be able to visualize the motion planning preview of this, and then eventually the ability to export to native robot language or send directly to the robot for execution. So these two we're hoping to wrap up, I believe, this month, and then we'll begin on the planning pipeline and profile editors, and then the motion planning workbench for pulling all these pieces together and being able to move the robot around and test out different tool paths and different planning scenarios. And that's it. I don't know if we're doing questions now or hold until the end.
We can probably take a question. I guess, like, I kind of made the comment here to Chris, right? I mean, like, this is potentially something like, you know, I have a lot of history with industrial robots, like on the teach pendant. I mean, right? So this almost looks like something that I could use to develop my application.
Yeah, so hopefully the goal is you'll be able to eventually configure your scan and plan. I think we've kind of just identified that style of application all from within this workbench. And then eventually it would have export tools to export this to, say, either a single ROS package or multiple ROS packages that then you could use this and deploy this on a factory floor or something like that. I think that's the big stretch goal.
This is Bharat. I have a question. The second part of this, I mean, after the URDF creation, I think the part about creating Tesseract packages and then doing the motion planning part. And I think you mentioned that you would be kind of automatically generating all those packages. One question is, I mean, is there a timeline on when you're looking at those packages should be ready? And number two, yeah.
Yeah, so I think near November, December. So the goal is all that, the planning pipeline, the editors and stuff, we're building out all of that. So what essentially it'll do is it'll get all serialized down to like boost serialization. So to kind of serialize it to a file that then will have like ROS nodes that can understand that file. And you'll just bring up a system and point it to that file, and it will automatically configure the motion planning server with those different profiles and pipelines, and then you'll be able to just call them directly. So it'll kind of, we're trying to take more of a model-driven approach where you do everything here and it exports a config file that then we have standard nodes that understand those files and can dynamically reconfigure them at runtime.
Okay. Yeah. Is it going to work something like the way we configure moved packages? Okay. They use a moved setup persistent and then use that and create all the moved packages. Is it going to be somewhat similar to that?
Yeah, it may be similar to that. We haven't determined on what the export looks like, if we're going to create a single package or does it export a set of these config files, these boost serialized files that then you just use those when launching, but we're still trying to figure it out. Most likely to start, it'll be a package that it exports just to simplify things. Or like a scan and plan application, but that may be too specific. We may have to come up with a more general approach in the future.
Yeah. Now, the reason I'm asking is, I mean, we may have an application which is not really a scan and plan, but we could use that intermediate part of creating a motion planning pipeline and planning server and all that. So I was just wondering if that's something.
Yeah, so the goal is it'll dump out a serialized file, and then the planning server node, like if you just wanted to do the pipeline editor, you would pull that up and you could export that serialized pipeline. And then the planning server you would just be able to pass that into the planning server and it would dynamically reconfigure it. So you could use different pieces of that, and we'll add the ability to export those files and import and update and things like that. The pipeline editor will be similar to behavior tree CPP. If you're familiar with that application where you kind of have these different blocks, you pull them around and connect inputs, outputs, things like that. So that's our goal, is to use the same underlying library. I think it was, I forget, it's a node library or something like that they used. So we're hoping to leverage that same package to do this for the pipeline editor.
Okay, thanks.